Okay, pre-calculus, we are still in Unit 8. We're on the second day doing logarithmic functions. So if you've got your graphing calculator, go ahead and take it out. Otherwise, you're going to need to pull up the TI 84 app. Okay, so basically, logarithmic functions, I had a tough time learning logarithmic functions when I was young. But basically, it is... Let's look here. Exponential and logarithmic functions are inverses of each other. Okay, so they undo each other. So the functions f of x equals log base b of x and g of x equals b of x are inverses if and only if f of g of x. So if I input g of x into the function f of x, and they end up undoing each other, and what comes out is what I put in, x. And then I input f of x into g of x, and they undo each other, and what comes out is what I originally put in, x. Then they're inverses, and you have to check both. You cannot just check one, you have to check both to see if they're inverses. So basically what this looks like is, if you're changing between logarithmic, if you have to rewrite an equation that's in logarithmic form into exponential form, this base to this power, okay, equals x. So b to the y equals x, okay, if it's in this form. So we're going to see if we can't practice rewriting these, okay. So the 2 is the base. So if I had to rewrite this as a log, it'd be log base 2, and then the y is what it equals. So log base 2 of 8 equals 3, and that makes sense because 2 to the third power equals 8. Let's try the next one. Log base 4 of 1/64 should equal -3. Well, let's check it. Does 4 to the -3, does that equal 1/64? Well, 4 to the -3 is equal to 1/4 cubed. Well, that's right. That equals 1/64. Okay, the last one, log base 4 of y plus 2, and I would put that in parentheses, equals x minus 1. So there you go. So now we're going to go ahead and try and rewrite the equations as exponents, and I think this is easier because you're just doing 5 to the third power equals 125. To the -5th power equals 1/32. And this is 5 to the 2y equals x minus 1. Okay, so this is, you try, feel free to look at it if you would like. I'm going to move on to example 3. All right, so to use inverse properties to simplify an expression, basically you just need to look at, if you think about writing this as a logarithm, okay, so this is log, how do I say? Okay, so basically log base 4 of 2x equals log base 4 of what? Well, it's just going to be 2x. Log 4 ends up canceling out, so that's just 2x. If you had to rewrite this as exponential as a logarithmic as we did before. All right, so now we've got a logarithmic function. What's going to happen is I'm going to need to rewrite this as this 25 is going to be 5 to the 5 squared, and there's still an x there. Because what happens is those end up canceling and you end up with 2x left. So really what this is saying is 5 to the what power equals 25 to the x power. And that's, if you rewrite this as 5 to the what power equals 5 squared x, you'll see that the what power is 2x. And then the last one, I think this one's a little trickier because I'd like to write this 8 in terms of the same as the base so that I can cancel it like I did the previous one. So if I write 8 as, how do I write 8 as a base of 4? 4 to the what power? Well, that's going to be 2 cubed equals 2x. All I did was rewrite the 4 as 2 squared and rewrite the 8 as 2 cubed. So now that the bases are the same, I can set the exponents equal to each other, and I can solve x's 3/2. So if I rewrite this as log base 4 of 4 to the 3/2, 2x. Well, now this is going to cancel, and I just have, I want to make sure this is right. Yeah, 3/2 times 2, those just cancel and end up with 3x. If you're having trouble with this, it's probably because you are having trouble with exponents. You need to go back and relearn exponents from Algebra 1. Okay, if you are asked to find the inverse of a function, you're going to follow these steps. You're going to switch the x and the y. Then you're going to isolate the exponential term, which in this case will be 10 to the y plus 3. So that's going to be x plus 4 equals 10 to the y plus 3. Okay, and then you're going to rewrite it as a logarithm. So this 10 is going to be the base. So log base 10, and I'm not going to write the 10 because if a log is in base 10, no one writes a log. Log base 10, it's just like 1x, no one writes the 1 in front of the x. Log base 10 of x plus 4 equals y plus 3. And we're asked to find the inverse, so we're really isolating y, and so we need to just move the 3 over and then we're done. So y equals log base 10 of x plus 4 minus 3. Done. Go to the second one. All right, so this f of x is the same as y. Okay, so if I go ahead and switch my x and my y, I get x equals log base 2 of y plus 3 minus 1. Okay, so now I got to move the 1 over. So x plus 1 equals log base 2 of y plus 3. So 2 to the x plus 1 equals y plus 3. Almost done. Y is almost isolated. Got to move the 3 over. So y equals 2 to the x plus 1 minus 3? Yeah, minus 3. And then since the original function had an f of x, we should really be using the inverse of f of x, which is looks like this, instead of y. If you would like to try the U-Try, it is right here. You may go ahead and do so and check your work in a little bit. We're going to move on to graphing logarithmic functions. It's similar to what we did last class, graphing exponential functions. Okay, plot the point. Okay, so basically, since, maybe I should start with here. If you're plotting the base points of 1, 0 instead of 0, 1 for the exponential functions and b1 instead of 1b. Now let me show you why. So just take a look at this, and you can write this down or not. But when you have y equals log base 10 of x, okay, and you go ahead and put a 1 in, what that means is 10 to the y equals 1. Well, that's going to be 0, because 10 to the 0 equals 1. So that's where we're getting that first number from. And then if you put the base in for x, okay, 10 to the y equals 10, well, that's just going to be 1. So that's where those two numbers are coming from. So that's why, oh, geez. Here, we have these base points, and those are the 2 points that we're graphing. 1, 0, and whatever the bases of the function, and then comma 1. Now, sometimes we will still use 1, 0, but sometimes if b is less than 1, we end up using 1 over b and negative 1. It's just easier, for example. And b is never going to be a negative value. I'll show you that in a minute. But if it's less than 1, okay, it's between like 0 and 1, it's a fraction. This means 1/2 to the y equals 2. Well, it's going to be easier to think about this y as a negative 1, because 1/2 to the negative 1 power, 1/2 to the negative 1 power, if you can think about that a couple different ways. You can distribute it, 1 to the negative 1 over 2 to the negative 1, and that equals, if you flip it, 2 over 1. You're going to end up with 2. right? So that means y equals -1. So that's why we use those. Otherwise, you end up having to deal with fractions, and we just don't like dealing with fractions. You can graph a fraction if you'd like. If you graphed a fraction, then the base would just be a fraction like 1/2, which is perfectly fine. So, all right, so where am I at? So you're going to plot, you just need 2 points. You're going to plot those 2 points. You're going to sketch the vertical asymptote, okay? And then you are going to multiply the y value by whatever a is, the number in front of the logarithm. And then you're going to make the horizontal and vertical shifts. Now, you can kind of do it in a little different order once you get comfortable with doing this. It just depends. So here's why you can't have a negative base. Okay, so this is why b is less than 1, but it can't be like a negative. So if you had, okay, check out this negative base. Okay, so I'm just like making this stuff up. So if I wrote this in exponential form, I would get 4 to the 1/2 power, negative 4 to the 1/2 power. That's going to be square root of -4. Well, wait a second here. That's not going to be a real number. So, and we're graphing this stuff. So we're not having any negative bases. So when it says b is, when it says b is less than 1, it means between like 0 and 1. Okay. So let's go ahead and start. So we're not going to do every single one of these, but we'll do enough because we're going to do some in class. So graph the logarithmic function, state the domain and the range, and then label the asymptote. So this -2 in front means to multiply all the y values by -2. This is a horizontal shift, right 3 and then up 2. So the 2 points that we found, if we're following the directions here, plot the base points, are 1, 0, and then the base comma 1. In this case, the base is 4. So here are the 2 points, 1, 0, and 4, 1. Okay, so when I take those points and I multiply the y values by -2, my y value is 0, so it's just that point's gonna stay at 1, 0. And then this one is gonna go to 4, -2. I'm gonna go ahead and plot those and start with those 2 points and then shift them. So one, and got to be careful with 1, 0. Okay, 1, 0 is not 0, 1. It's 1, 0. Make sure you plot it correctly. 1, 2, 3, 4, -2. Okay, so now, all I've got to do is shift them in a different color. I will shift them right 3, 1, 2, 3, up 2, 1, 2, and maybe put that in purple. And then this one, I will shift right 1, 2, 3, 1, 2, and put that in purple. Oh, I forgot to draw my asymptote. My asymptote is going to be at, normally it's at x equals 0, but we've shifted the whole graph to the right 3. So in light yellow, 1, 2, 3. There's my asymptote. Now you kind of have an idea about where the graph is going to be because now these 2 purple points, I'm just going to connect and have them approach the asymptote. Done. Terrible graph, but you get my point. All you need are those 2 points. And then the domain is from 3 to infinity, not including 3. And the range is -infinity to +infinity, and the asymptote is x equals 3. All right. I'm going to run out of time, so I might as well just do another one. If you want to watch and pay attention and do this one, great. Okay, so this is left 2, down 1, multiply all the y values by 3, 1, 0, and then the base 1. So I'm going to go ahead and do that, 1, 0, and then the base 1 has to be multiplied by 3. Okay? Plot those points, 1, 0, and 3, 3. My asymptote is going to be at x equals -2. Okay, basically you're just setting this parentheses equal to 0. Okay, so I'm almost done. Just take it. Oh wait, did I shift it yet? No. Got to shift it. Left 2, down 1 in red. Left 2,